Hello, welcome back to Learn Physics. Today's topic also we are discussing with the numerical part of our electricity chapter, and in this chapter already we did two videos for our numerical part, isn't it? So this will be the last video which I am doing for the this numerical part for this chapter. Okay, next I will start with the next chapter, that is optics part I will start. Okay, because most of the students, some of the students told me like for their school it started optics, so I thought I'll start with optics also, and then we will come back to this electricity, electromagnetic radiations and all. Okay, then after finishing our the entire theory part, we will again be doing some more numericals. We will again doing some more numericals. Okay, and the previous year's questions also we have time. Okay, so we will be doing that one. So today first question is the values of current I and potential difference V across a resistor is given here. Calculate the resistance. So I and V are given. So how we can find out the resistance? So if we need to find out the resistance from I and V, okay, that is data are given. So first we should draw the graph and then find out the resistance. So I and V means which, this will be stating which law? Ohm's law, isn't it? So I is here in x-axis and V will be here in y-axis. Volt, we should write down the unit. Here it is ampere. Okay, and then here current we can give it as 1, 2, 3, 4, 5, like that we can give. Here also we can give as 2, 4, 6, 8, 10, then 12. Next I am giving 14. Okay, so here for 0.5 it is 1.6. So if it is in the graph sheet means you can do it very clearly, that 0.5 where it is, and you can draw the graph. See, for 1 it is 3.4, and then for 2 it is 6.7, and then for 3 it is 10.2, 10.2, and 4 it is 13.2. So it will be. So we will be getting a straight line graph like this. We will get a straight line graph like this. So for each current value you can find out the potential xy coordinate. In maths how you are doing, the same way you can do it here also. Okay. Now our aim is to find out the resistance. How we can find out the resistance from the graph? See here, any one small triangle I can consider. Okay, so if I am considering between 2 and 3, see this one and this one, 2 and 3. If I am considering a small triangle, this will be 10.2 and this will be 6.7, and here it is 2. So here form y2, this is y1, and here it is x2, the second one is x2, first one is x1. How we can find out the resistance? Resistance will be equal to the slope of VI graph is equal to slope. What is the formula? y2 minus y1 divided by x2 minus x1. Here what is y2? y2 is 10.2 minus 6.7. What is x2? 3 minus 2. So we will get it as 0.5. 3.5 divided by 1. So we will get the answer as 3.50. This is how you should find out the resistance. By calculating the slope of the graph, you will get the resistance. Understood? It's not mandatory you should use the same thing, and you can use the any formula, any one. See, in between this you can use, or see, it is obeying the Ohm's law, that is 6.7 and 3.4 if you are getting, it won't be obeying Ohm's law. So it won't be a complete straight line like this, it will slight variation will be there, that is okay. But because experimental method always it will be slight variation will be there. So you don't worry about that one. And then 3.3, 3.4, 3.5 in that range only we will be getting. Okay. So clear now? What is the how we will be finding out the resistance? Shall we move to the next question? So another question is, which graph shows parallel combination? See, here in the question actually it is given as the series and parallel combination of two resistors are given in the circuit, and in the diagram you can identify which one is parallel and which one is series. So one shows the series combination and another one shows the parallel combination. How you will find out the series and parallel combinations? See, here it is V and this is I. So VI graph. It's a VI graph and parallel series combination, how it is connected with the resistance. See, from VI graph we can find out the resistance. How we can find out the resistance? By finding out the slope, which has, if slope is more, then resistance also will be more. If slope is less, resistance will be less. So here which has more slope? Yes, B has more slope. So resistance is more for B. Which one will be parallel or series? Which one will be having more resistance? Series resistance will be having the more. Series will be having resistance will be more. For parallel connection, resistance will be less. Remembering, right? R equals R1 plus R2. So it is resistance will be added up in series connection. So resistance will be more in the series connection. But in the parallel connection, resistance will be less. So which one shows the series connection? B is showing the series connection. Then what about A? A will be having the resistance, low resistance value. So it shows the parallel connection. So which is showing the parallel connection? A, which has less slope, will give the parallel connection. So while you are answering this question, the slope of A is less. Series and parallel connection, while we are doing, parallel connection will be having very less resistance. So the A is the answer. Okay. So next one is, an electric motor takes 5 ampere from a 220 volt line. Determine the energy consumed in 2 hours. So we should find out the electric energy consumed. How we can find out the electric energy? How we can find out energy? Any formula we learned about energy? Electric energy, rate of electric energy is called as power. Rate of electric energy is power. So power equals E by electrical energy divided by time. Rate of electric energy is power. So how we can find out electrical energy? Power into time. So do we have power with us? No, but we have current and voltage. If we have current and voltage, can we find out the power? Yes. So what are the given data? I equals, current equals 5 ampere, potential difference equals 220 volt. So we can find out the power using the formula V into I, that is 220 into 5. So it is equal to 1100 watt. Okay. Then determine the energy consumed in 2 hours, not in 1 second. Isn't it? So 2 hours we should. So that is in hour. So better this one you can convert it into kilowatt. Kilowatt, how we will convert? That into kilowatt divided by 1000. So it will be 1.1 kilowatt. Okay, then now we are going to find out the energy as P into T. What is power? 1.1 kilowatt into time is 2 hours. So it will be 2.2 kilowatt hour. Like that you will get. So understood how we will be finding power means you can directly apply the formula, but energy if they are asking how to find out. Energy means power, electric power into time as energy. Okay, understood? That's easy, right? So shall we move to the next question? Next is compare the power used in 2 ohm resistor in each of the following circuits. 6-volt battery in series with 1 ohm and 2 ohm resistor. 4-volt battery in parallel with 12 ohm and 2 ohm resistors. So we should find out the power used in 2 ohm resistors. Okay, so we have first one a 6-volt battery which is in series with 1 ohm and then it is in 2 ohm. So we should find out the power used in 2 ohm resistor. This is 6-volt battery. Second case it is a 4-volt battery which is in parallel with a 12 ohm and 2 ohm resistor. This is 12 ohm and this is 2 ohm. This is 4-volt battery. So how we can find out the power used in 2 ohm resistor? Okay, here voltage is given and resistors are given. So first we should find out the power across 2 ohm. Power, what is the formula? V into I is there. I is V square by R is there. I square R also there. So here which one we can use? If we want to use V square by R, we should, because we need the power across 2 ohm only, isn't it? So we need the power across 2 ohm. If we are using V square by R formula, we need the voltage across 2 ohm. Or we can find out, use the I square R formula if we have the current across 2 ohm. So any one you should find out. So here shall we find out the current first? So what is the total resistance in the circuit? R is equal to 3 ohm. So and voltage is given as 6 volt. So what will be I? V equals I into R. So I equals V by R, 6 by 3, that is 2 ampere. 2 ampere we got it as current. So then power equals I square R. So 2 square into R is 2 ohm, isn't it? So we are getting it as 8 watt. Okay, so the next one, 4 volt and 12 ohm and 2 ohm resistor. We should find out the power across 2 ohm resistor. So what is the formula to find out the power? V square by R. Since it is parallel connection, voltage will be remaining the same. So what is V here? V equals 4 volt. Power across 4 volt equals, across 2 ohm equals 4 V square divided by R is 2, because we need to find out the power across 2 ohm, isn't it? So 16 divided by 2, that is 8 watt. So here also we got the power as 8 watt, here also we got the power as 8 watt. That means the power across in both the connections it will be same through 2 ohm resistor. Here one thing you should understand that, see, even if it is a 2 ohm, resistor, you should, if you are using V square by R formula, you should find out the voltage only across 2 ohm. Okay, don't take the entire formula, entire voltage, then it will be wrong, because it is in series connection, voltage will be changing from resistance to resistance, but current will remain the same. Okay, but in parallel connection, voltage will be remain same for all the circuits. Okay, clear? Understood this? So next question is, how many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? So here, how many 176 ohm resistors are required? So all resistors are connecting in parallel. Okay, like that, how many resistors are required to carry 5 ampere current on a 220 220 volt line. So voltage is given as 220 volt. Current is given as 5 ampere. Okay, then resistance, then how much it will be? R equals V by I. So it is 220 divided by 5. So we will get it as 44 ohm. 44 ohm is the resistance. So to get a total 44 ohm resistor, how many 176 ohm resistors should connect in parallel? So how we can find out that? See, if n number of resistors are there for in parallel connection, then effective resistance will be R by N. Okay, N resistors each having a resistance of R, then effective resistance will be R by N. Okay, this is the formula. That one you can buy after. Okay, so R by N. So here we are getting it as 176 is the R divided by N. That will be equal to 44. That resistance is 44. Total altogether we should get the effective resistance as 44. So 176 divided by N equals 44. So what will be N then? 176 divided by 44, that is 4 resistors will be required. Okay, so understood, if we have N resistors with us, everything is in parallel and each having resistance R, then effective resistance formula is R by N. That one we can give. So if all are connected in series, how it will be? Yes, 5 into R. That will be the resistance. Okay, clear now? So the effective resistance is R by N if N resistors are connected in parallel. So 176, our effective resistance is 44 here. So the N value we got it as 4. So how many resistors will be required? 4 resistors will be required. Clear now? So hope all of you understood all those things, and then see you next video. Okay, so please don't forget to subscribe the channel. Okay, thank you.